Hi everybody, this video is going to be over the intermediate value theorem. So the intermediate value theorem describes key property of continuous functions. So it's important to know that it has to be a continuous function to be part of the IVT. Okay, so what this tells us is that over a continuous interval a to b, a function will take on any value between f of a and f of b over the interval. Okay, so more formally, it means that for any value of L between f of a and f of b, there's a value c that's in between a and b, for which f of c equals L. So again, what it's saying is if this is my a and this is my b, okay, then this over here is f of a, and this up here is f of b. Okay, there is some value in between here, L, that L, when I do f of c, or whenever I do c, and f of c is going to give me L. Okay, so if I had some elaborate continuous function here, okay, it tells me that there's some value f of c where I get L that's going to be in the middle of all of that. Okay, so let's go ahead and go on to some examples. So let h be a continuous function on the closed interval of -3 to 4, where h of -3 equals -1 and h of 4 equals 2. Which of the following is guaranteed by the intermediate value theorem? And there's only going to be one answer for this. So what we need to understand is what we can eliminate based on h of c equaling 1, h of c equaling -2, h of c equal -2, and h of c equaling 1. Well, is 1 and -2 falling between my values here? Okay, if we look at that, -2 does not fall in between -1 and +2. So that helps me eliminate B and C. Now, what we need to understand is the second part of it, that these right here are talking about our x values. Well, our x values for this interval are -3 to 4, which means D would be our correct answer. Looking at number 2, let f be a continuous function over the closed interval -3 to 2. A few values of f are given in the table. Which intervals must contain a solution to f of x equals 2? Select all that apply. So we want to know what must contain a solution if f of x equals 2, meaning my y value equaling 2. So the first interval of x values is from -3 to -1. Well, -3 to -1 are these numbers right here. So if I look at the y values, would 2 fit in between 6 and 1? Yes, it would. So that would be one of our answers. Then if I look at the next interval, -1 to 0, that's right here. Would 2 fall in between the y values of 1 and 5? Yes, it would. Looking at my next one, I have 0 to 2, so that's these values over here. Is 2 going to fall between 5 and 3? No, it's not. So that answer doesn't work. And we've already selected 2, so none of the above is going to work either. Okay, so number 3, use the intermediate value theorem to show that f of x equals x cubed plus 2x minus 1 has a 0 at the interval 0 to 1. Well, first off, we need to know that the word 0 means solution, root, or x-intercepts. Okay, we need to know two things for this to work. First, we need to know, is f of x continuous? And since it's a polynomial function, okay, f of x is continuous on the interval 0 to 1, then the second thing we need to know is we need to know what f of 0 is and what f of 1 is. So if I plug in 0 into my equation, I get 0 cubed plus 2 times 0 minus 1, which tells me that f of 0 equals negative 1. When I plug in 1, I get 1 cubed plus 2 times 1 minus 1, and that would tell me that f of 1 equals 2. So what we need to know is 0 between negative 1 and 2? Yes, it is. 0 is between f of 0 and f of 1. So our answer and what I'm looking for, the first part is your work. Now the actual answer, the free response part. F of x is continuous on the interval 0 to 1, and 0 is between f of 0 and f of 1. Therefore, f of x has a 0 on the interval 0 to 1 by IVT. Okay, so this part right here would be your answer, where the part written in blue would be your work that is required to be shown. Okay, looking at the next one, number 4, this is a previous AP question, a free response question. So a car travels on a straight track. During the time interval, t is greater than or equal to 0, is less than or equal to 60 seconds. The car's velocity, v, is measured in feet per second, is a continuous function. So there's that key part, is a continuous function. Has to be continuous. Okay, the table shows some selected values below. So, part A. For t is greater than 0 and t is less than 60, must there be a time t where v of t equals negative 5? Justify your answer. Well, if we look at it, where in the table would negative 5 fall into a y value? It would fall into a y value around here. Okay, negative 5 is in between negative 10 and 0. So what we have is by IVT, there must be a time when v of t equals negative 5, because v of t is continuous on the interval of 35 to 50, and negative 5 is between v of 35, which equals negative 10, and v of 50, which equals 0. Okay, so there's our explanation of why this works. Okay, number 5, what we need to know is let g of x equal tangent x. Can we use the intermediate value theorem to say the equation g of x is equal to 0? Has a solution where x is greater than pi over 4 and x is less than 3 pi over 4? Well, what we need to know is the graph of tangent. So the graph of tangent looks something like this. Okay, it has some asymptotes at negative pi over 2 and positive pi over 2. And the function looks something like this. Okay, so if we look at it, we notice that pi over 4 is going to be somewhere over here, and 3 pi over 4 is somewhere on the other side of that asymptote. So therefore, g of x is not continuous at pi over 2 because tangent x has a vertical asymptote at x equals pi over 2. So therefore, it is not continuous on that interval. Okay, moving on to the next part. Okay, so number 6 and 7, we're going to answer these 3 parts to our question. Okay, determine if the intermediate value theorem holds for the given k value. So to determine that, we know that f of x equals 1 over x minus 2. Our interval a to b is 2.5 to 7. And our k value that we want to see if it holds true is 1/4. Okay, so first off, we need to know, is this continuous on the interval? So if we look at it, that asymptote is at 2, therefore at 2.5 to 7, if we extend it, is continuous. So f of x is continuous on the interval 2.5 to 7. Okay, now we need to determine what f of 2.5 would be and what f of 7 would be. And then we need to determine if 1/4 is in between those values. Okay, so f of 2.5, I plug that into the bottom. I get 1 over 2.5 minus 2, which gives me 1 over 1/2, and 1 over 1/2 is 2. Then I plug in 7, so 1 over 7 minus 2, which is just 1 over 5, which is 1/5. So therefore, 1/4 is between f of 2.5 and f of 7. Okay, so since we did that, let's move on to part B. If the theorem holds, which it does, find a number c for which f of c equals k. If the theorem does not hold, give a reason. So what we're going to do is we're going to set f of c equal to k. Well, f of c would be if we plugged in c for x. Okay, so f of c equals k, which would look like 1 over c minus 2, which is equal to 1/4. I'm going to cross multiply. When I cross multiply, I get 1 times 4, which is 4, and I get 1 times c minus 2, which is c minus 2. I add 2 to both sides, I get c to be 6, and it works, which means when my x value is 6, my y value is 1/4. So on our graph, to graph this, here is 6 right here. So somewhere on the graph, if we were to extend it just a little bit, we would see that it crosses at 6 at 1/4. Okay, looking at part number 7, or question 7, same questions apply. Now, we do need to understand where this question comes from. Okay, it does look like half of a circle. Okay, so if we had x squared plus y squared equals r squared, and we solved for y, that would give us y squared equals r squared minus x squared. And then we take the square root of both sides, so y equals plus or minus the square root of r squared minus x squared. Okay, and we're just looking at the positive half of that, but that's how we came up with this half a circle or semicircle equation. Okay, so if we look at this, one, we know that this function is continuous by looking at the graph on the interval -2 to +2. So we do need to fix that. I do have a typo right there. So f of x is continuous on the interval -2 to +2. Okay, so now we need to identify f of -2 and f of +2. So this is our part 2. Okay, so when we identify f of -2, I plug in -2. Well, -2 squared is +4. 4 minus 4 is 0. Square root of 0 is 0. F of 2, 2 squared is 4. 4 minus 4 is 0. Square root of 0 is 0. Okay, so I get 0 and 0. So this means that IVT does not apply because f of -2 equals f of +2. Okay, there's no number or no y value that we can put in between 0 and 0. So we can't guarantee anything outside of that y value range. So therefore, IVT does not apply, and that would be our answer for this one right here. Okay, so if you have any questions, make sure you write them down and you ask me in class. Thank you. Have a good day, Rangers.